Well, welcome back. This is step one in our probably long journey to try and understand 3D rendering, and we're going to be using C++. But we're also going to be taking a comprehensive look at 3D graphics and rendering, and we're going to be looking at the various components that go into it so that we get a deeper and more comprehensive view other than just copying and pasting C++ code to get a renderer and we're not really sure what we're doing. So as I mentioned in the intro, which I suggest you take a look at that to find out exactly where we're going, the first thing we're going to look at is images. And I'm going to take a couple, maybe 3 videos to look at images in detail. So you may ask, why do I have to look at images? Images are basically a photograph, right? It's a pretty picture, and that's all I need to know. Well, no, not at all, for a number of reasons. The first one is everything you do in 3D rendering or computer graphics, the end result is an image on your computer screen, right? All of the hand waving and all of the 3D rendering and OpenGL and ray tracing and everything comes down to putting an image on your screen. So if you don't understand where you're going and what the image has to look like and what its components are and what it's comprised of, well, if you don't know the end goal, then you don't know how to get there, right? So you really need to understand images, not only for that reason, but also because in 3D rendering and computer graphics, especially 3D rendering, images are used for a lot more than just as pretty pictures. Keep in mind, an image is basically data that you use to tell the computer what to put on the screen. And you can use images for more than just the visual picture, the pretty picture. You can use it as like a big matrix to tell the computer, okay, here's more information in the form of a big image matrix, and I want you to use that data to help you figure out how to draw something on the screen. So you're going to encounter that throughout the process of understanding 3D rendering in many ways. We're going to talk about image maps and depth maps and all kinds of alpha channels and all kinds of things associated with images that aren't actually the image itself, but they are components that help you figure out how to draw the image. So we'll get into that quite a bit in these first couple or 3 videos. But I encourage you to stick with it so you really understand what an image is and what all the components of an image can be, because guaranteed you're going to be using them and you don't want to be scratching your head, what is that? So we'll first start out with some basics on what is an image and what are the component parts. So we're going to start out here with understanding images. Now, it may seem like, why do I need to understand images? Well, it's really, really important that you understand the basics behind images because they form the foundation of what you produce. And also, when you're doing texturing, you're doing compositing, a lot of that comes down to image manipulation. You've got to understand what's inside an image and all of the aspects of an image in order to do that correctly. So we're first going to start out with understanding the basic concepts behind images and how computers deal with images. And then we're going to move on from that to understand some of the more complex aspects of images and the things you can do. So we're starting out here. I'm in GIMP, which is an image processing program. It's free. I recommend it. It's very nice. You can also use Photoshop. But GIMP is great for doing image processing for all kinds of things. And what we're going to do, we're going to use it here to understand some of the basics behind computer graphic images. So here we're starting out with an image I got off the web, beautiful photograph of the mountains. And you can see it's got many, many colors in it. It's got greens, it's got blues, yellows. And it's very finely graded, it's very smooth transitions, very high resolution, just gorgeous image. So there are some basic things you need to understand about images at the outset in order to understand what's going on here with your computer and how it handles images. So this has got blues, yellows, greens, grays, and lots of variation. So how does a computer do this? How does it put this image into GIMP so that you can see what it is and you can work on it? Well, there's a couple basic things you really need to understand, some concepts. And that is, the first one is how it handles color. Color is extremely important if you're going to be working on 3D because it all comes down to color and color values. So the question becomes, how does a computer reproduce the yellows here and the blues and the greens and the grays? Well, there is a basic concept that you really need to understand that's been around for many, 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 many years. And it is that any color that you see, that you can visualize, can be reproduced by a combination of 3 other colors. And those are called primary colors. And those primary colors are red, pure green, and pure blue. So basically you can take any color in this image and make it based on certain values of red, green, and blue. So what does that mean? Well, let's go into this sunrise or sunset area and use my color picker, tools, color picker, and I'm going to click on this image and find out what values it has. And here I've got my color picker information for that image, and here's the color I picked. Here's a visual representation. And over here on the left, I've got R with a number, G with a number, and B with a number. So what that's telling me is I can reproduce that particular number, that color that I picked, by taking 254 reds, 225 greens, and 185 blues, and I will exactly reproduce that color. Now I can go over here, do the same thing, and you'll see it's darker color. That's 214 reds, 166 greens, and 120 blues. So I can go anywhere in this image. I can go up into this blue sky, and here we've got a blue. You can see that it's 96 red, 141 green, and 198 blue. So as you expected, it's mostly blue. It's 198 blue, mostly blue, with less green and much less red. And I can go over here in the grass area, and I've got 101 red, 82 green, and 23 blue. So what that's saying, again, a very, very important concept, is any color can be generated by adding together certain amounts of red, green, and blue. Again, extremely important concept that you're going to be seeing over and over and over when you're doing 3D or computer graphics. Now, the next important concept we need to understand becomes evident when I zoom into a small part of this image. Now you can see this is a very beautiful, sharp corners, high resolution, beautiful changes in color image. But let's say I zoom into this area right here. So I zoom in, and wait a minute. I'm starting to get a very blocky image. And you can see that what looks from a distance to be a sharp edge is actually these little blocks, blocky image. And anywhere I go, I've got these little blocks. And they're here too, but since it's all about the same color, it's hard to distinguish the blocks. But anywhere I go, this image seems to be comprised of blocks. Now, this is a very important concept in image manipulation. These blocks are called pixels or picture elements. And every image you see on a computer is comprised of millions, often millions of these little pixel blocks. And an important thing to understand about each pixel is each pixel gives only one color. So I've got my color picker here, and I'm going to select this pixel. And no matter what, if you look over here, I've got 128, 110, 124 RGB. No matter where I go inside that pixel, it doesn't change. It's the same numbers. And then if I go over here to the next pixel, 142, 126, 139, it's all one color. So all of this beautiful gradation in color is actually fooling your eye into believing it's a smooth color change or a sharp edge, when in fact it's all little blocks of individual colors. All right, again, very important, each pixel is just one color. It's not two, it's not three, it's not a gradation, it's one color, and it's defined by how much R, G, and B are in that pixel. So, extremely important. Each pixel is one color, and each color is defined by how much R, red, G, green, and B, blue are in it. Now, so you look at this and you say, wow, there must be a lot of blocks of pixels in this image to make it look so smooth. Well, there are. If you look up here in the top of the window in GIMP, it says it is 4,896 by 2,760. So 4,800 by 2,700. So if I go over here, I can select a color, and in my color picker that says I'm at pixel X, which is over in this direction, 24, and Y, 32. So I select, and there's 24, 24. And if I go over here, it says I'm at 48, 52, and 28 down. And if I go in this corner, it says I'm 48, 60, and 27, 44. So you can see I start out at 0, I go over to 4,895, and then down to 2,759. So that's a lot of pixels. And if you do the math, you can see that the number of pixels is over 13 million pixels in this one image. So I've got 13,512,960 pixels, and each one has an RGB value. So now you're starting to see this image is really complex. There's a lot of information here. So that's a very important point. So now we've got that each image is comprised of many, many pixels, and each pixel has only one color. It's not a graded, gradual color. It's one color. And it's all fooling your eye into making it seem like it's a very smooth image with sharp edges. Now, if you're in a computer, how are you going to represent this image when it's actually red, green, and blue values that are going to comprise this image? Well, one of the cool things you can do is you can break it down into what are called channels. And if I go into GIMP, here's my image. If I go into this next tab, it's called channels, and I click on that, and you can see I've got 3 images that are black, white, and gray. One is labeled red, one is labeled green, one is labeled blue. So what happens is this image is stored as actually 3 images. So in your image file, so for example, let's say this is a JPEG that you download. Inside that file, that .jpg computer file, is actually 3 what are called grayscale images, right? So it's got, each pixel has a value that describes how much red, and this part of the image has a pixel value to describe how much green, and this has a pixel value to describe how much blue. So we can see that. What I've done is I have decomposed this image into these 3 and made them as separate images. So let's go in here and pick a point at the peak and check its value. So what I'm going to do is I've got this point right here. I'm going to check its value, and it is pixel number 673 by 250, this pixel right here. And it's got a value of R equals 100, green equals 142, and blue equals 200. So what I'm going to do is I'm going to go into my red image and find that exact same image, that exact same pixel. So before I was at 673 by 250. So I'm going to go in here and find 673 by 250. So here's the pixel right there in the red image. 673 by 250, and the value is 100, which is exactly what it says it should be in the normal image. 673 by 250 should have a red value of 100. And I can do the same thing for the other two. So the green will show that pixel value is 142, and the blue will show it's 200. So now I've got very interesting information here that this JPEG image on your computer is internally stored as 3 grayscale images. And the value of each pixel in each grayscale image describes how much red or green or blue is in the final image. So the computer takes these 3 images, goes to pixel 673 by 250, and says, okay, red, how much is it? And it will say 100. Go in the green image, how much is it? 142. Go in the blue image, it will say 200. And it adds those together to get this final value up here. Okay? This is extremely important information on how images work. These 3 images are called channels. So you've got your main image, and it's comprised of different channels that describe how much red, green, and blue are in it. Okay? Extremely important that you get that concept. So now that we've taken our beautiful image and broken it down into red, green, and blue component images, and here they are, I'll cycle through them. Here's the red grayscale, the green grayscale, and the blue grayscale. And again, it shows how much red, green, and blue are in the image. But now that we've broken them down to these 3 separate images, we can start to think about, hey, I can take this, for example, red image, and I can tweak it. I can darken it or lighten it to add or subtract how much red is in my final image. Same with green and blue. So I've got these 2 images, and I can operate on them to change my final image. And this is extremely important, and this is something you're going to be encountering over and over again when you're working on texturing, when you're working on image compositing. Most of what you're going to be doing is taking grayscale images that represent something about your final image and modifying the grayscale images by lightening or darkening or doing something with the grayscale values to change your final image. Again, very, very important if you're going to do compositing with something like Nuke, or you're going to be using GIMP or Photoshop, or you're going to be texturing or shading in Blender or something like that. You're going to be doing a lot of grayscale image manipulation to change your final texture or image. Okay, so now that we've seen that our image actually contains 3 sub-images, which are grayscales that contain color information about the main image, you might think, well, why can't we add more images to provide more information? So, for example, let's say I've got this beautiful image and I want to superimpose something on it. And what I'm going to do is I'm going to take a model I made in Blender real quick, and I'm going to put it into this image. And see, I can move it around. All right. So it turns out that this image that I brought in is a render from a Blender render. This image has information on these pixels surrounding this fighter that say, okay, instead of giving me a color for this fighter image, don't show me anything about the fighter image, just show me whatever's behind it in this background of the mountain picture. Okay? So that's called transparency or alpha information. Kind of confusing terminology, the alpha, it's actually a transparency, but in computer terms, they don't know what transparent, there's no such thing as transparency to a computer. All it knows is what color do I put in this pixel, all right? Do I put a color from the fighter image, or do I put the color from this other image, the mountain picture, right? That's all the computer knows. So the alpha of this fighter tells it whether to put the fighter picture in these pixels or to put the background. So what we've done is we've added to this fighter image, and I'll go to the fighter image, some information that describes how transparent parts of the picture are. And you can see here's the picture. Everything other than the fighter is transparent because you've got this transparent background. So I can go to the channels for the fighter and see, hey, wait a minute, red, green, blue, alpha. So I've added a image, a grayscale image that defines transparency. So now it's not just 3, now I've got 4 images describing this fighter render, and I'm using one of them to describe how transparent it is. So where it's white, it shows the fighter. Where it's black, it shows whatever's in the background. In this case, it's the image of the mountains. So when you think about it, yeah, you can start adding channels and information to an image that give you a lot more information other than just the colors. So in the next video, we're going to do part 2 in our journey to try and understand images. And I think we're going to take a look at other types of information that accompanies an image, other channels of information that tell the computer how to draw the image. And I think we're going to take a look at probably a depth map, which has information on depth. And we'll show how you can provide additional types of information in maps. And when you start doing 3D rendering, you're going to be using those a lot. You're going to be using them for materials and bump maps and depth maps and all kinds of information about your object. So you really need to understand the concepts here. And after we talk about that, we're going to talk about actually what's contained inside an image file. So we're going to use Notepad++, that's Hex Viewer add-on, to actually look at the internal contents of a very simple image file to see what's actually in there. Because if you're going to be loading images and textures and materials into your renderer, you need to know what's inside the image file so you know what to do with all the data. You know what the data is and what to do with it all. So I encourage you to join us for the next video. Otherwise, thanks a lot and have a great day.